Hi, everyone. Hope you guys are having a fantastic day. It's crazy to think it's already Wednesday. Uh, Man, this week has gone by pretty quick. But for today, I want you to work on the Fed activity, and that actually took all day today. Okay, some of the math is actually a little complex. Um, I'm actually going to help guide you a little bit. Okay, um, so I'm going to present my screen here. Okay, so hopefully you can see my document camera. Let me grab a piece of paper real quick. All right. So some of these problems, what they kind of look like is you'll have to utilize, like, especially some of the first ones. So force is equal to the gravitational constant, mass of object 1, mass of object 2, r squared. So when you're looking at this, you're going to have to look, so force is equal to mass times acceleration as well. So when it asks, like, when the mass of Earth changes or when the mass of the sun changes, how does it affect the acceleration of Earth? Well, if we look at that, let's say mass of Earth times the acceleration of Earth is equal to g mass of Earth times the mass of the sun over r squared. Well, if we look at this, I'm going to zoom in. If we look, the mass of Earth cancels the mass of Earth. So if the mass of the sun increases, that means the acceleration of Earth has to increase. Okay? Whereas if the mass of Earth increases, well, the mass of Earth has to increase here. So those two would cancel out, and that's a different problem. Okay, that's the next problem. So hopefully you can see that. Then when you get to the very bottom, like the bottom part, when you get to number one, what you're going to actually have to do is you're going to have to use force of gravity as mass, object 1, mass of object 2 over r squared. Okay? Now, what you got is the mass. Let me grab my paper, grab my equation sheet real quick. So what you're going to have is, once again, mass of Earth times the acceleration on Earth is equal to g mass of Earth times the mass of the sun over r squared. Okay? Where the mass of the Earth cancels the mass of the Earth. And remember, it's 1.5 times the sun. So you're going to have to do 1.5 times the mass of the sun. Okay? That will give you the acceleration on Earth. Now, my acceleration equation is v squared over r. So plugging this into A, I should be able to solve for v. All right? And then I'm going to plug v into my 2 pi r equation. And that should give us time. Now, time will be in seconds. You will need to convert that into days and see how close you are. Okay. Ooh, I'm going to scroll down. My bad. All right. So hopefully that makes sense. Okay. And then I will actually go over the answers to this tomorrow. I will post all the answers. And we'll check to see how we're doing. Okay. Right now, I'm planning to have a little quest on Friday, just to go over some of this material, so we can move on to some momentum ideas. But if you have any questions, please feel free to let me know. We can set up a Google Meet, or I can try to respond through email. If not, I hope you guys have a fantastic day, and we'll see you guys tomorrow.